Hello. Just making sure everything is working for you.
Seems to be.
This is on. It doesn't work with PowerPoint. It does work with PDF files and Google Slides. So just FYI, I can try to click it. Probably won't work. But you can use the arrows. Great.
Thank you.
You're welcome.
Are they giving a part?
We're just gonna fact check. Oh,
Because I know how the chairs are in this working group and they're very loud. Let's see. Glasses, yes.
Just 3 IETFs ago, I could see everything. Now it's just all blurry. No, it's too large, you mean? Yeah. It's not moving properly. Huh? Yeah, it looks okay. Yeah, but Tony is not here. Who's the first presenter?
Tony.
Well, I can connect to Jabber. You can just start now.
Okay, so we are going to get started now. Blue sheets is circulating now. Please sign. Note well. Please note well. If you have not read it before, read it. We already got a note taker. Sandy, thank you. Jeff is going to be the Jeffer scribe. We have a simple agenda today. We have 3 presentations. So we'll just get started on that. And at the end, we'll talk about the working group status and the plan. So, Tony, are you ready?
Yes.
Okay.
Where's the pushy? Oh, you want to advance? It's almost simple. All right. Okay, we're ready? Cool. So, hey everyone, I'm just giving you an update what was going on between the last 2 IETFs. We are at version 6, and I think after this, the 7 will be coming after IETF, and will be pretty much raft. So wow, can I read my? Oh yeah, I can. You probably can't. So we published 6 on the Git repos to 7, and those are changes since the 5. And they mostly came from Bruno having implemented a bunch of things and discovered that a couple of things are still unclear. All right. So we had this V4, V6 thingy going on. So there was also discussion on the list that have been brought up by 3 or 4 different people, Alvaro originally as well. And we had to add 2 or 3 clarifications, and we had to omit something from the draft. Okay. So first, when Bruno was sending V4, V6, right, when he switched off an address family, he stopped sending it, but he was still processing the received frames. So it led to an asymmetric adjacency. So we had to add to the draft that, sorry, it was the other way around. When he switched off the AF, he stopped receiving it, but he was still sending it. So on my side, I had both AFs, and he on his side had only one AF support. So we had to add clarification. I thought it was obvious that a node that is not receiving frames in an address family, lies, hellos, must also not send them. Okay. Then we had discussion on the security envelope because we implemented the full security envelope and interrupted. So it wasn't clear that you can look behind the security envelope and use the fields before you validated the fingerprint that are enveloping them and protecting them. A subtle thing, we had to basically extend the spec by saying that you must not access any value until you validated the fingerprint. Okay. Then we had the nonce wrap up on the security envelope, where basically the nonce goes up, 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 and you can wrap around generating a 0. And the value 0 also is an undefined nonce. So we did not see that that would drop adjacency, but just to be better safe than sorry, we added on that when the nonce is wrapping up and you hit the 0, you automatically has to jump to defined value 1. Okay. Then we had this interesting case where we're saying that unless you're in L3, in a 3-way state, you must send just zeros as nonces, undefined. Only when you're in 3-way state, you start to mirror each other's nonces. Now, the problem is that if you decide in a 3-way state to reset the adjacency, the original spec was saying that you basically start to send zeros, right? Because you must send zeros. And that's how the spec remains. The spec was correct. But it leads to the fact that the guy on the other side has to wait until he times out. Because you're sending him one-way or 2-way with all zeros, which he will ignore. Because the spec says that in 3-way, you must ignore 1-way and 2-way lies. Otherwise, you could build a very simple attack to reset the adjacencies. So as an optimization, we allow that you may send one one-way or two-way lie. With the nonces, you know, because you're coming down from three-way. So you're coming down for three-way and you really want to reset the adjacency on the other side fast. And the only way you manage that is if you show the guy correct nonces on the one-way or two-way. So you're allowed to do that once or twice. We basically say as an optimization, you may do that, which will allow you from a three-way to reset the remote guy, sending a one-way with the correct nonces once before you reset them to zero. Does it sound nitty-picky? Well, that is a full-fledged interop blind after two people implement it without talking to each other. All right, then we had something on the lifetimes. We softened up the lifetimes. All right, so basically we had this rounding up of lifetimes to prevent a generation of fingerprints. And when you talk through the stuff, we realize it actually doesn't buy you much when the nonces advance very aggressively. So we weaken it from a should to a may, okay? Then what we did is we added a couple of optional things to the schema. So the first thing is, and there was demand from a customer actually looking how they would deploy that, was that we added into this when we're sending out the node ties with the description of the adjacencies, we added in whether the adjacency is protected by a key, outer key, which means the pairwise key. And the reason was that the customer wanted to look at the top of the fabric where they see the whole fabric, right? You have the topology, the full topology at the top of the fabric. And just like we have miscabling, they wanted to see whether the fabric is secure. Generally, I was very surprised. The security is actually generating astonishingly high interest rates. I thought it would be like one of these things we must do because we're like a modern protocol. But the discussion how to secure fabric, rollover keys, is actually evoking a lot of interest. By a lot, I mean 2 or 3 large customers really wanted to know what the model is. And there was a direct output. They basically want to look at the top of the fabric, understand whether they have all the links on the fabric protected, right? Trusted. The other feedback that was from, again, deployment and doing all kind of things already, like how would I hook up my controller and do all kind of funky stuff. On a prefix, we have optional, see them as flags because they're Boolean. One is telling you whether the prefix is a loopback and the other whether it's directly attached to you, right? So that way you can say whether it shows up from some funky place by some funky means, injected by a controller or something. Simple stuff, optional, didn't even increment the schema. That's all? No, we had more stuff. All right, and there was a discussion on the router requirements. Sorry, there was one more I didn't put on the thing. Also an optional element, but it escapes me. But then we had a discussion where we said a Rift router may support a V6, but must support V4. Oh yeah, and that was why the addition was necessary. And the objection, justifyingly so, was that V4, we all push hard to obsolete V4, right? So that way it will never go away. On the other hand, the V6 is nowhere close where people will be able, everyone will run the V6 pure fabric. Good amount of people do, but we're by far not there yet. So and the reasoning was the following, that if a fabric does not have any V4 addresses, which is highly desirable, the only thing you get are V6 addresses, ND coming up, right? Once you have the V6 and you exchange the V6 lies, because you can send V4 lies, so no V4 addresses, if you imply that you can V4 forward, which is absolutely possible, right? Because you have the gateway resolution. Well, you don't need the gateway, you have the MAC address, right? ND gives you the binding, the MAC binding to the gateway. So you can very fine forward V4. You get a V4 frame. Yes, you don't have a V4 gateway, but the only thing is a MAC address. So you just go to the V6 and you just get the MAC, stick the MAC and forward. Works like a charm. no tunneling, no special configuration. So works beautifully. But of course, you must assume that the guy is capable of forwarding V4, so you don't black hole. So once you remove this requirement, that goes away. So what we do on the lies now, on the hellos, you must indicate whether you support V4 forwarding. And that way I know whether you will black hole my V4 frame or not. The intention is, of course, not to support weird deployments where people will start to build fabric partially forwarding V4 and partially not, and computing partial SPFs. The spec will allow you to do that, but that's not a red hole, right? So that way we allow people to build V4 and reliably understand that the V4 forwarding will work, albeit they have no V4 addressing, right? While allowing easily to migrate to pure V6. So that's not as convenient for the customer, but I see how INETCONNET put out a spec saying it must, a router running this must support V4. And there was a confusion for a bit where people were thinking that that implies that, so based on the charter, we must support both address family, and the spec does that, any combination. So the sentence was related to router requirements if you want to deploy such a protocol. So this sentence is gone, and we have a new information element indicating IPv4 forwarding. So it is tedious, but this is not really like grinding it to the point where people try to switch the stuff and say, how is that supposed to work? And we have two implementation really, you know, stressing all kind of weird corner conditions on the protocol. All right, so we had a full implementation of security envelope on the open source on my side, and we had a full interop now finished. So that's results. So Bruno, I have Bruno's presentation, which is a lot of interesting things that we hit. But basically, the Python RIF has a full implementation of the single plane. We have that since a bit, and we'll be releasing the stuff, and already with the 0.7 draft implementation, which means all the, I'll talk about what will come into 0.7. So all those changes plus some more. The security envelope interoperability is finished, so we have that done. We will be releasing the 0.11 Juniper, which is basically a full implementation, and we will be releasing in public, basically for public consumption, because when we release a binary package. We'll be releasing a much wider envelope that we're already giving actually to customers, which includes a Thrift API allowing a full configuration of the protocol during runtime, and the full operational state API as Thrift services, as well as real-time analytics API, where we're basically writing real-time the whole database and a lot of operational state of the protocol into Redis database. And we're also including open source library, which allows to deserialize all this stuff with writing the analytics from the Redis database real-time.
We've got comment from Bruno on Jabber.
Yeah.
On slide 2, it is actually safe to reject a packet based on field after the fingerprint before validation of the fingerprint. If you go to slide 2.
Yes, but there is no need unless we would do what Bruno suggests and I reject it, which is protecting something like Rift Major, because I see absolutely no benefit, but then you would look before the fingerprint. Right now, there is nothing you can look before fingerprint that makes any sense. Well, sorry, nonsense.
Let me read it first and then.
Yeah, okay.
Answer. For example, it is safe and efficient to reject a packet because of out-of-range nonce before validating the fingerprint. However, if you accept a packet, you must validate fingerprint before taking any protocol action.
Okay, so that may still need a small grind, because Bruno is absolutely correct. You can and should look at the nonces before the fingerprint, because you can reject it without being exposed to a computational attack. Because the fingerprint computation is an envelope where if someone forces you to compute a lot of envelope, they may just basically have a denial of service attack surface against your computational resources. So Bruno is correct. We have that in the minutes. Who's taking the minutes? Because I do not want to miss that, please.
Bruno will continue on mailing list. So it's not going to get lost.
Yes, please, that shall not be dropped. Pascal.
So I was just thinking about your discussion about forwarding IPv4 about V6 adjacency.
Yeah.
And so we can echo all the words that you pronounce, which are correct on the document, but there is actually a RFCF 5549, which explains all that. So
Is without tunneling? I don't
yes,
think that.
5549 is just, you have a V6 adjacency, you resolve the MAC address, then you can forward V4.
Perfect, because that was what I was looking for. I was only finding the 7 series, which was all about tunneling. Okay, excellent.
So
Please do poke me. We will reference this
that would
document.
simplify the text.
Absolutely, yes. Well, the text is not explained that now. The router requirements were kind making it implicit, right? But it would be great to have the 5 series reference where we basically don't even have to explain how you do it. Okay, yeah, because I refuse to put it into Rift spec. Like, I'm not here to describe how to build a forwarding path, right?
So this was specifically to avoid DOS attack.
Sorry?
To the previous part, sorry,
Yeah.
I'm just reading.
Yeah, okay. Hope people can follow that. Once implementing can do that for sure. All right, so back to that. So that will be out in probably 2-3 weeks. Stuff's all ready, but as usual, the wheels need grinding. Then we went through the early directorate reviews already and got, 3 hours worth of sitting around and cleaning the stuff up. So like I said, the router requirements for Rift discussion has been had, and we removed the router requirements will be going completely 0.7, and we added the indication whether v4 forwarding is supported. Lots of editorial, better wording. I sent the stuff out to the mailing list with the result, what we do, most accept that. That will go all into 0.7. And that's it from my side. So then Bruno, as usual, put me on the spot. He's having fun. I have to talk. Questions? Nope. All is safe. Lots of people already on the plane. All right. So this is the whole output of the interrupt stuff. Okay. All right. The usual location, Python, reference implementation, not associated with any vendor, no bribes accepted, almost there. All right, so since 104, Bruno implemented a very good chunk of it. So he implemented the positive disaggregation. He implemented and actually very well debugged the flag reduction. So he put a very nice document explaining how flag reduction works and the properties it achieves in Rift. Good reading generally if you're interested in flag reduction. And the whole security implementation went in, and we interrupt the stuff, and he put actually, so he had this security analysis, so he wrapped it up. He has the security review report in even more excruciating details with all the possible attacks, whatever we imagine. Actually, a very good comment came in that we'll probably add a sentence on the security section specifically for the host requirements. Because now we're talking about protocol which can extend all the way the routing domain into the host, which is about the first time something like that is being done. And the discussion was around the fact that the host is, of course, much more likely, we're talking data center server, is much more likely to be compromised. And what kind of attack envelope that could present against the fabric. So the output is nothing particularly exciting. You basically have to, on the host, either have a very strict rate limiting how much state you push into the protocol, and on the Tor, you have strict limit how much state you're willing to take up from a host in terms of all of a sudden someone showing you 1 million Kubernetes prefixes. Probably not a good idea, right? Or they try to pretend there's 1 million people behind them, which if you deploy that with the leaf flag is not possible, but let's say you do a full ZTP and someone could try to build an artificial topology and inject it into you at the Tor. Okay. So what is still not in the Rift Python? Multiplane with negative disaggregation. Frankly, there are very few people in the world at large scale who have the luxury to run a multiplane, but there are people who run on multiplane on the very cheap end of the spectrum, surprisingly enough. So negative disaggregation, east-west links are not implemented. A multi-neighbor state, which is the extension to the FSM we did when multiple people show up on the same Ethernet, right, which is a mis-cabling. Key value, which is optional, policy guided, which is optional. Bruno cannot set the overload bit. Clock comparison, which is the specific extension for mobility on the fabric. If you want fast mobility on the fabric, which if you don't support is just fine, you advertise without clock. Fabric bandwidth balancing, which is the computation where you bandwidth balance node bound, which given that he's running on Linux, I do not think that Linux has any kind of support for next hops which are unequal. So they're ECMP but unequal weight, but I would have to double check. More test cases, so he's always adding test cases. And we do not look at the label binding segment routing at this point in time, simply no demand. BFD, because Linux doesn't have anything, so the best you can do is probably reflecting from the Tor. So the multicast is kind of open discussion. Pascal will probably talk about where they stand with the multicast, or maybe Jeffrey. And no plan to support in Rift Python the Yang data model. All right, so positive disaggregation. I don't want to explain necessarily again how positive disaggregation works, but basically when, so do I have, oh yeah, look at this. Okay, so when spine 1 loses a link to a leaf, that's the simplest case. Then basically spine 1, 2, and 1, 3 have to show the specifics of the leaf 1, 1, so this guy doesn't black hole it. So they all, except to the default route, they add the disaggregation of these leaf 1, 1 routes only, okay? Yeah, so that's basically the scenario. 1, 2, and 1, 3 show a mount specific, and all the traffic towards leaf 1, 1 is being offloaded of the spine 1, 1, which would black hole it. And that, as we know, that is non-transitive. So if you have a level above that needs to disaggregate, the disaggregation does not flow south. It's unnecessary. So multiple levels and multiple parts of the fabric may disaggregate at the same time if you have multiple failures until you're guaranteed not to black hole and not to this is the other problem, to bow tie through the fabric, because these guys could go like this, up, like this, and come down, which in fact can happen if those guys are in process of disaggregation. So this guy may black hole depending how much connectivity he has, or he may pump it up and end up bow tying through the fabric, which is also a highly undesirable condition when people are running those fabrics from experience, because of course it completely breaks any of your blocking probabilities that you laid out the fabric for. All right. So as usual, well-written prose, so very easily understandable narrative, what it's all about, and how to go into this reference implementation, which can dump you all the state, show you what is happening. You know, it's excellent to learn how the protocol works, to walk through these kind of feature guides that Bruno is putting out. It's always enabled, and we know the algorithm is you detect the black hole, you trigger the disaggregation as much as you need to prevent black holes. You advertise the southbound, so the disaggregation always goes south, just as negative. You never disaggregate to the top of the fabric, and you install the more specific in the table. All right. So here we go. He looks at what are the southbound adjacencies, and based on all the reflection that you get from other people, you know what you're not having compared to the people at the same level. So people at the same level, these are north adjacency, this is south adjacency. You realize, okay, I'm missing the adjacency here, right? And then Bruno has all kind of nice, like interface states where he can tell you, look, there's people who are forcing me to be partially connected on this interface because this is all running actually not in containers, you're running on namespaces. And then you trigger, positive disaggregate, which is this. Then the stuff gets flooded. So this is, you see the link state database, right? Which direction do we flood? Who is the originator? What is the type? It's a positive disaggregated prefix because the TIE are all annotated. And you see what's inside it, which metric. And this will be the SPF that you run on it. So those are results of the SPF as far as I remember. And it shows you that it also is picking up beside the defaults that go through 3 gateways. You're picking a disaggregator that goes through 2 gateways at a different cost. And you have, those are the interfaces again. And this is the routing table. So that's the RIP, all type broken and so on. You see who installed the stuff. And again, what are the routes? And you only see the gateways. Flood reduction. So why flood reduction is because obviously when you flood in this scenario, every level that floods up, you get an enormous amount of copies coming from the bottom, which is all exactly the same information. And we're talking right now easily 64, 128, 256 fan out, so radix, which means 128 down, 128 up, something like that, maybe 64 up, 96 down. People have different ratios. Right, so basically you get overwhelmed. Right, you get both overwhelmed in terms of how much you have to replicate, and you also get overwhelmed with simply when the incast that you're seeing, no matter how fast you flood. All right, so basically what we would like is somehow to limit number of copies that we're getting to some kind of a safe number, right? That will not partition when we lose some links, right? Give us a margin of safety, but on the other hand, not burden us with excessive amount. So what Rift constructs is basically, okay, so this is an example of what happens when the red and the green guy starts to flood. When everything is fully connected, the red node would generate 4 copies. The 4 copies will hit super 1. This leaf will do the same thing, red and green topology, which basically leads to 4 identical copies going through the fabric. And again, with 4 doesn't seem excessive. 64 is nothing special, right? As a radix here, or even 1632, these things add up very quickly. So what we really want is somehow out of those 4, prune out 2. So let's assume we're happy with 2 copies, which is a good number normally. So instead of, so of course we have to flood to all those 4 guys because each of them needs the information of the red node. So there's nothing to reduce here. But from here on, what we like is that only 2 of the spines send a copy to the super spine, right? And a very subtle problem that starts to emerge is that if everybody down here picks up the 2 same guys, then you have, the problem that those guys may get completely overrun with the replication plus, processing of the stuff. Well, so actually replication, and then of course making sure that the flooding went through. So ideally, we want each of these guys pick up 2 different guys, so that we load balance. And of course, we don't want to synchronize those guys again because we don't have any reflection. The leaves are not even aware how many of them are at this level. That's how you scale this stuff up. So non-trivial to achieve, went through a couple of iterations and final emerging solution largely based on Pascal thinking. Feature guide again, this one I really highly recommend. It walks you very carefully, again, with like all the CLIs and so on. I don't know whether Bruno dropped CLIs into this one, we'll see. But it's a nice English narrative explaining to you how you achieve such a thing, right? What happens is basically is that those nodes run a kind of an election algorithm, distributed election algorithm. So each of them picks 2, right? And the algorithm is run in a way that's based on their node ID, and this node ID, everybody ends up with a pretty nice, spreading it evenly. The story gets more interesting, of course, if connectivity is partial, because you have to pick up possibly more than two to get a double coverage at the top of the fabric or the next level up, right? So things get a little bit more interesting very quickly if you consider partial connectivity. So Rift Python implements an example algorithm. And the funny thing is that if you think farther, each of these nodes can actually pick a different algorithm if they choose without endangering the whole thing very much. So that's a surprising property. So he implements, we gave a nice algorithm that has a lot of entropy. If everybody runs it, it will spread nicely. But it is very, very resilient if you try to do something slightly funky and you do other choices. Unless everybody's really stupid and pick the first and the second, then like, well, okay, right? You have no entropy. You know the ID has to somehow get into the entropy. So the whole show comments is on his implementation. Okay, so he even included something. So when you look at the flood reduction, what you find is you have an interface and you're talking to someone, obviously, that's the system ID on some interface. And you know how many grandparents he has, because that's what you get on his node tie. You see that, even if you're south. All the adjacencies are included, and you know which is north or south. So you know he has 4 grandparents, and here is the anomaly, right? This guy has 1, which means that he lost 3 links. So you have to account for that. This I will not even talk about. We basically put this thing into equivalence groups. So we say all those 3 guys are actually equally good when you choose them, and then we mix them up. We run like a mixer. So those are, what are they called? Hash groups? I forgot what we called them. It's used for the Fisher-Yates type of hashes. And what happens at the end, after they're ordered in these equivalents and meshed up, you basically start to pick them and you assign them as a flat repeater, which means we signal to them, if you see my originator tie, do please repeat to a level above. And if you say false, means I'm sending you my information, please do not keep repeating it. The whole thing is actually vaguely similar to Manet flood reduction, right? Which worked very well, but we couldn't use directly because they take advantage, as far as I remember, very heavily from the fact that the wireless medium is broadcast, which we don't have, right? Our medium is the opposite of broadcast, actually. We have link-to-link everywhere, right? Okay. So then, what you can also see from Bruno's code is when you look at the grandparents, which means not the parents, but the grandparents, you can actually see whether they've redundantly covered, which means they have at least a degree of 2 of replication, right? So one link cannot break it, and then you have to figure everything out and wait until you figure out the flood reduction and then go flat until you have everything everywhere. So it's resilient. And again, the degree is up to your choosing, and actually every leaf, every node can choose their own degree. One can run with, I need double coverage, the other 3 coverage, doesn't matter, nothing changed. And that's probably looking from the other side where you see whether you are the flood repeater for the guy on the other side. Tons of stuff. You see, that's basically the adjacencies metrics, right? Which neighbor state are you? Which direction is the neighbor? What's his system ID? Interface, which is the thing that people appreciate a lot when they debug those fabrics. And it's like a trivial thing, but it's very hard to do with traditional protocols. It's very easy to see whom you're talking to on the other side. So you have the name of the guy, right? You know who it is, but not only this, you see his interface name. So it's very easy to go like, oh, okay, I hook up into this guy on this port. So that's what Rift gives you, right? You always know where I'm going out and whom do I hook up on which interface when I'm cabling. All right, so you can disable that, of course, but it's enabled by default. And I think Bruno allows you to play with the redundancy factor. And the similarity factor is that's how you balance depending on how many adjacent the guys have node bound, because you can have different strategies when you pick who is repeating for you, right? You can pick up the guy with most of this is node bound because he gives you the highest coverage. You can just do the opposite. You can pick up one with the least, right? Because he will repeat the fastest, right? Or the guy who has the most CPU or whatever not. It really, like I said, it's highly resilient. As long as you put your node ID as entropy into the whole algorithm, the stuff will spread, you know. And depending how, it really doesn't matter. It's bloody resilient. As long as you put a little bit of entropy, the stuff just load balances, all right? All right. Security. So now here comes the most delicate part of the work. What happened? Okay, so again, here comes Bruno. Nothing until it's like in a beautiful English write down, everybody can follow and learn from. So truly a reference implementation in the best sense of the word. So we have the outer keys per interface, right? We protect, I'm not showing in the law, where we protect twice. So we do origin protection, which means when I'm originating information, I am putting my key signature around that, which means the content cannot be changed. But then when I break up an adjacency, I have the option, it's all optional, right? We will run without keys, fine. I have the option to only accept the adjacency if we agree on fingerprint of a key, no acceptable key, and then every packet, when it's a tie and it's inner protected, gets wrapped into the outer one. Right, so on every adjacency we have an outer key, which is adjacency specific if you want, and we have the inner key, which is really signed by the originator of the information, which is really only of interest if you do LSPs, ties, LSAs, right? The stuff that floods all over the place. So, right, so we call them inner keys. Bruno tried to push them to tie origin keys, but actually we can protect more stuff like PSNPs, right? Tire tides also with this key. So it's not clear what will happen. So I prefer to call them inner key, right? It's the originator protection. Of course, multiple algorithms because we show the key and then we show what is the fingerprint length that we use. Right now we are running off Bruno will correct me, I think SHA-2 which looked to me like the sweet spot. I think there was some discussion on the list why we picked the key. 512 is kind of biggish. So I think I'm running off SHA-512 or 256. I don't remember, which is agreed on something. And then you need library support for all the languages, and it has to be RSA, this or the other. We have support for key rollover. And then, of course, you know, statistic logging, because once security fails, it is hell to debug, because the answer is basically no. Okay, so why is not very good with security, right? How to find out. So we have this YAML file which describes the topology which we use to interact. So because we both can bring up these virtual topologies, right? And we can read the same format to see the topology description without running a lot of virtual machines or whatever not. So we added all kind of things where you have to describe the keys, and each node can say, right, so what is my origin authentication key that I'm using? Which one will I accept? And what am I running per interface? What is my active authentication key on the interface? And what is the accepted keys on this interface? I have more stuff which Bruno does not support, which is all kind of strategies what I'll do with the key if it shows up, which is in practical deployment very useful. There's all kind of loose permissive thing which says like, if you don't have a key, it's okay. If you have a key, I verify it, otherwise I'm okay. You know, all kind of variations that has evolved over the last 20 years. And the OSPF and ISI has nicely led the way, right? So there's very sophisticated implementations. All right, so when you look at the security of an interface, so that has proven necessary, right?
Tony,
Yeah.
bunch of comments from Bruno. So Linux does support an SQL cost multipass, and it is SHA-256.
So it's 256, wonderful, and we do have the support in Linux, which means if you get that as a host version, you will actually see that it will load balance based on bandwidth on the fabric, not bound. If it's correctly implemented. So it balances the suggested algorithm. Again, it doesn't matter how it balances. Every leaf can do what they want because it's a loop-free algorithm. It's value-free, right? So you send it any way you like, it will not loop on your fabric. We'll get there. But if you have one metric, you probably want to mesh something up, which is a mixture of your administrative metric plus available bandwidth. And you can provide all kind of knobs and things, right? The spec gives you one example and suggests how to do something like that, but again, it's highly resilient. So to debug the security, you have a lot of things which are mostly saying 0. And those are the reasons why you wouldn't not process the packet further, right? So there's the envelope may be missing. You don't accept the key ID. The fingerprint is incorrect, but there's lots of other stuff. All kind of empty fingerprints and so on. So like a page full of reasons why you would not process it. So here you see that it accepted a non-empty outer fingerprint and accepted non-empty origin fingerprint. And we had a lot of discussions, well, that's exaggerated, but we had good amount of discussion about all the performance, right? I mean, what will be the throughput? Because Rift floods at, depends how well you implement it, but something like having, 20 or 30,000 information element coming into the database per second. So we're not even talking flooding rates. That means that is the consolidated flooding rate on all the interface you're running. Is nothing special, right? So the interfaces may got cumulative at 100 to 100,000 packets. I don't know. Which are most interesting, how fast is the database sucking up? And of course, at those rates, we were very interested, will the encryption even hold up? And no problem at all. On the generic CPU, I mean, you can crank insane numbers. Once you move into like 1024, 204A territory, it starts to get tricky. So Bruno put out actually, I think, an email on the list where he measured the stuff. What is the, practically speaking, an envelope you can run on generic CPU? And then of course, if you have multiple cores, so there's all kind of tricks. But you can run a very solid security without much of a burden. At very high rates with lots of information. All right, so interrupt testing, security was the focus. We fully automate the whole thing, right? The whole thing get chucked on the usual continuous integration things, no manual like pushing and kicking things. No one has time for that. We are also too easily bored. Everything is passing at this point in time, so that's custom image I threw pre-release package on Bruno because we were iterating back and forth. He found one thing on my side, I found a thing on his side. So what did we learn? The fingerprints per set is the envelope parsing and so on was not a problem at all. So like accepting the key and parsing the key and going after fingerprint that basically just flipped on. Nonce reflection. So here, Bruno didn't believe me when I relaxed the nonces, right? And I was very specific that you have to be fairly leisurely how you push the nonces up and how you what kind of nonces you accept, how much leeway do you give on the nonces. So so first, of course, it's very different from most PFISIs. And by the way, the Rift security has been learned directly from DoD. So it's based on work I did for DoD where I've shown up with they wanted the most secure IGP possible. And when I've shown up, they gave me a solid hiding. And then I learned how to really build a practical best of breed routing protocol security for IGPs. BGPs, of course, different thing. So the security we have now covers both intra and inter-session attacks and without need to store anything in volatile storage, because those are the big precondition, right? So there's nothing to attack. It boots empty, no state. You can attack or store the state. And then no matter whether you try to attack within the session or after reboot, a new session comes out, you try to attack, we have protection for both. Bruno thought that he'll go better than the spec, and he was advancing his nonces very, very aggressively. Or pretty much any packets, anywhere, anything, just push up my nonce, right? And that led to, and what the spec specifies says that if you see a nonce within 5 interval compared to what you gave, you're okay with it. So you have this slip of 5. Now, I give you a interesting input. Bruno asked me why you would even accept something that is higher that you announced. So I walked him through implications of heavily parallelized implementation of routing protocols, where you may have multiple clocks advancing in your implementation at different rates. So it may happen that on that you will find yourself receiving something which is ahead of what you think where you are. Yes.
So Bruno is saying that he has published a security report that has all the results in it.
Yes, so there is the security review. I didn't see I'm not sure what he's talking about with the publishing. Okay. So Bruno was advancing the stuff so fast that when the FSM was like revving up and already doing some kind of flooding stuff, he would be falling out the 5 window, right? So he was resetting the session. So he had to back off and do pretty much what the spec suggests. And then everything went up nicely. And even despite he was slightly concerned that he's a little bit more leisurely, the FSM is very resilient to attack. So whatever you throw at it, it will behave properly, and you cannot attack it and reset the sessions, and bring up the session if you don't have the proper credentials. What draft was changed to, because what emerged out of that, trying to reset this FSM and so on, I think it was Bruno's input. We decided to send the remote nonces 0 in both 1 and 2 ways, because I think I was more relaxed there. That was the result. So you cannot, because we couldn't negotiate the keys early enough always. So the 2-way will be already nonce protected. Details escape me. It will be in his report. Okay, so he said already there is a very detailed review report. He updated on the second version. So that talks about all possible attack vectors, what we saw, the finesse of the whole thing. Any questions? I know that was comprehensive, but at this point in time, we'll basically jump up and down. We got an early review from the security one of the directorate. We addressed all the stuff a good while ago. Implemented interrupt. What we got was we have been granted the exception by the AD to actually keep the security section within the spec rather than publish, security consideration draft, which in my opinion makes much more sense. Just like keeping the requirements and the security on the spec rather than flooding them around. No questions? So the only real discussion I saw were these router requirements that was floating around. Then that's it. All right.
Thank you, Tony.
So no, sorry, there was a good discussion with the ZTE, but that was fairly early. That was about the V4, V6 negotiation as well. Yeah, so it's very close to that.
Okay, so we had the update on the protocol and on the implementation, and next on the agenda is the RIPS applicability statement draft.
Good afternoon. I'm Sunny Zhang from ZTE. This presentation is for RIFT applicability. We have many co-authors for this draft. Let's see the background of RIFT protocol. We know that the class and fat tree topology have gained predominance in today's networking. And from the many deployment experiences, we got some key points for it. The first one is extensive configuration, because we know that there's many devices in the DC fabrics. So the configuration burden is very great for the network administrator. So it's a key problem need to be solved. And the second point is that the leaf node has the same database with the other node in the network because of the IGP key filter. We know that we always use all OSPF or ECs in the DC fabrics, but every node in the network will maintain the same database. So the leaf node will have the same database with the other nodes. It brings great burden to the leaf nodes. Of course, we know that maybe the leaf nodes is only a host, so he can't burden so many routes and the database. And the three key point is the flooding duplication, because we know that it's a very special connection in the DC fabrics. So as Tony just said, in this network, if we use traditional IGP flooding function, the duplication cannot be avoided. So the bandwidth will be wasted, and the normal flooding of the database will be impacted. Let's see this picture. We know that Rift can be used in these fabrics or metro fabrics, and building coupling or internal router switching fabrics or cloud CO. All these networks have the same or the like topology, like fat tree. So how Rift can be used in these networks? We know that Rift is a new dynamic routing protocol for the cross and fat tree topologies. Because the key feature of Rift is it uses different advertisement for different directions. It's more like a link state protocol where point north, and it's more like a path vector protocol where point south. And the Rift protocol is fully automated construction based on detection of link. So it can support ZTP. ZTP means zero touch provision. So it can greatly reduce the burden of the network administrator. You can just plug the device in the network and it will work. And the Rift protocol can also minimize the amount of routing state held at each level, such as in the leaf node, the leaf node has only the default route in the normal situation. If some links has broken, the key feature of the Rift is positive disaggregation will solve this problem. So there's only default route or some small amount of specific route will be held in the leaf node. And also, Rift can automatically province and load balances topology, flooding exchanges over a sufficient subset of links, as Tom just said. And the key point, I just mentioned it, is the automatic disaggregation of prefixes. So, according to these key features, the suboptimal routing and black holing can be avoided. And also, Rift can support, the Rift allows traffic steering and rerouting policies because the good extension. And also, it allows loop-free non-SMP forwarding. And it can support, it can automatically support the rebalance of traffic towards the spine based on the bandwidth available. And also, it can provide the mechanisms to synchronize a limited key value and key value data store that can be used after protocol convergence. So from it, we know that there's many advantages in Rift routing protocol. And also from it, we know that Rift can also support horizontal links and vertical shortcuts. So it's naturally that Rift can be used in the networks that is listed here. That's all the applicability statements. Any question?
Okay, thank you. So right now the document is at the version 01, right? It's still a individual draft or?
Yes, we'd like to call for working group adoption. Yeah.
Okay. Yeah.
For me.
Hi, Sumit Mugavardhan, Juniper Networks. Just one comment in the previous slide. Do you want to also add some statement about scalability and number of adjacencies, which could be a plus
Which one?
for the
Sorry.
applicability?
It's implementation specific, so.
Tony P. Juniper. So yeah, a number of adjacencies you can support is largely implementation specific, but the scalability of the protocol, based on the fact that it summarizes up, right? And you have much less information. Also the, what you call it, blast radius, that is architecture of the protocol.
Okay, yes. I've learned about anything. Now that you mentioned working group adoption, I wanted to mention that what the charter says is that we want a applicability statement that talks about how to deploy and configure Rift in different topologies. What I think this document does is it basically summarizes the Rift features, and then it says, oh, because it has those features, I can use it in fabrics.
It's my fault because during this meeting, I pay little attention in the use cases expressing, but in the draft, there's many texts on the use cases for it. Yeah.
I looked at the draft and I didn't read it all, but it looks like there's maybe one or two paragraphs for each of the use cases. I don't know that that's a lot. I don't think that's a lot. And I don't think that in one or two paragraphs you can talk about how to deploy and configure for each one of the use cases. So again, with a grain of salt, I haven't read the whole thing, but it seems to me that this draft in the current form is not what we want to meet the charter. This sounds more, and don't take this the wrong way, but this sounds more like a marketing summary. You know, this is all the great things about Rift, which is great, but it doesn't tell me if I need to apply Rift to a fabric, to a DC fabric, for example. What considerations should I take when I configure a deployment? You know, why, or, you know, whatever other considerations are.
So we can add more detail in the use cases, right? Okay,
I think there should be
can
more
do it.
detail in use cases.
okay.
So I think clear message to co-authors to work more on it, to clarify use cases, to increase number of use cases, and
Okay.
Okay, 20p Juniper. So you have 5 use cases. I mean, what do you need? Is there a magic number we have to cross?
Add more detail about it, right?
No, it's more like a question to AD. So first is, what's wrong with 5? And the second one, we are under the curse of our own design, because if you run Rift in ZTP, there's literally the configuration cover with one sentence, switch top of the fabric on the top of the fabric, and you're done.
I'm going to thunder running it. So there's nothing wrong with 5. There's nothing wrong with 7. There's probably nothing wrong with 1. So what we want, or what I thought we agreed from the beginning when we did the charter with the applicability statement, is to say, okay, now here we have the protocol specification. This is how you use it. Now, you just said something interesting, which is, well, this is so easy to just configure it here and then that's it. So maybe there aren't that many considerations. We specifically mentioned this in the charter because, I want to make sure that when people are going to use, when people are going to use Rift, that they know how to deploy it. That if there are deployment considerations, that people consider them. And so that, I don't know, if I need to think about, I don't know, the size, the breadth, whatever it is, that is considered there. Now, hold on. Just like security, you could have a section in the big document, which is already 140 pages, to say, these are the deployment considerations. There's an RFC that I forget which one it is in the 5000 series. I'm going to say 5143, but whoever's the fact checker, you can check, that talks about deployment and manageability considerations. And so it talks about, if I'm implementing a new protocol, what kinds of things do I need to think about in the network? If I'm, stuff like that. That's the type of thing I want to see. It may be that, the protocol is so simple and so easy to use that you don't really have considerations. And that's fine, as long as you explain why, and it's not just, oh, Rift is so great, we don't need to do anything. We want to do something in there.
Tony, so yes, I remember as an RFC like that. So thanks for this reference. Yes, required reading. Where we had deployment consideration was basically miscabling, right? That's where the stuff pops up. On the security, the stuff I saw with Bruno was more implementation considerations where he had to loosen up his stuff. Otherwise, keys are keys, but we can put something in, like you used towards PFISI as key management, same thing. I mean, if that contributes anything. And we had the configuration, which is just embarrassingly, little stuff to say really about. And I throw one thing where I saw deployment considerations really as if you really want your loopbacks, right? So I had something about the loopbacks and what are the gotchas and loopbacks if you lose parts of the fabric.
Right, so don't tell me, put it in the document. And just for the record, or 6 minutes, it's RFC 5706.
Thank you.
Dmitry Afanasyev, Yandex, as one of the co-authors of the draft, at least some parts could be more detailed. It's sort of on me because, analysis was done later, so it's not in this draft, but of particular in DC fabrics, if you want to do the homing hosts and keep amount of routing state small, there is an RFC how to do routing in DC using BGP, but it becomes really, really difficult to both minimize state and do the homing, for example, because it essentially requires doing conditional disaggregation based on non-local information. Very difficult to do without a lot of additional logic.
Thank you.
Okay, so looks like we need to have at least one more revision before we can go to get ready for the one group adoption. Okay, thank you. Thanks, our AD. So those are the, okay, 20.
All right, so here's a question, AD bound. So do we have to last call everything as a package? What's the deal also with LSDR? Because at this point in time, the protocol spec is very thoroughly cooked with 2 implementations. And I have people ask me, when will they have the RFC for the RFPs and their like? So is there a policy here, or can we go to the last call of the protocol spec while all this stuff, of course, is absolutely necessary and committed to, and so on and so on?
I'll go with unroutingly. So you said, what's up with LGR? That's a different working group. Two, do we have last call everything? I think when we did the milestones, we said that we would process together the protocol and security, which is now one document. So no, that means that you don't necessarily have to last call everything together. So we can progress protocol. Now again, if, for example, in the case of this applicability statement, which we put later in the milestones, if this is going to be folded into the actual protocol spec because it's so simple, then it's the whole thing. But otherwise, we should do it. Don't make promises on the time frame for getting an RFC.
Oh, I know that. That didn't imply to deliver a product on time with quality. Just, allow to try to get a product out.
John Scudder. A friendly suggestion, mostly to the chairs. Jeffrey, I think what I heard while I wasn't reading my email, which I of course wasn't doing, during the discussion of the applicability draft was present the applicability draft, and then there were, some criticisms of it, whatever, and then you said, well, maybe it's not ready for adoption yet. And gosh, it sounds to me like the working group is discussing a draft that the working group is chartered to produce, which sounds to me exactly like what a working group is supposed to adopt a draft to do. Like normally you don't, wait until a draft is perfect before adopting it. You adopt it when you're like, yeah, this is kind of what we're supposed to be working on, and then you insist that it be perfect at last call time. But it's your group. I mean, run it the way you want to.
So I think the intention was just to address Alvar comments, respin another revision, and then go, not to delay it for another 6 months. Thank you for comment.
Okay, so we've heard this updates on the base protocol, the implementation, and this applicability statement. Let's look at the working group status and have some discussion on it. Let me see. Okay, present here. So as we all understand now, the 06 revision has been posted. We did a writing directory review by Russ. Thank you, Russ. And the authors and Russ had extensive discussions in the last 2 days, and they already agreed on the changes that need to happen. And the 07 revision will be out soon. The plan is to issue the working group last call right after the 07 revision, and this does not have to wait until the applicability statement to be ready. And so originally we thought that we would call for the adoption for the applicability statement. I think we'll wait for the next revision. And the YAN spec, it was adopted last time. There's still some minor updates that need to be done, and we'll issue the last call after that. And multicast draft, we discussed the multicast ideas and at last IETF meeting, and we put out the 00 revision, the initial draft. We still need to put in more details, especially on the ties format and things like that. And we were not ready to discuss it further at this time, but we will have another revision out, and then we'll discuss it more the next IETF meeting.
After update of Young draft, we will request Young doctor's review as well before working on Pascal.
And then there are some other side work that future work needs to be done. We have put out initial drafts before, have not actually worked on those yet. So we'll continue on that after the main items are taken care of, or when people have more bandwidth. That includes the PGPs, segment routing, and modcast stuff. Any thoughts, comments, any new ideas? I know that Pascal has some ideas on what kind of other work items can be done. We can talk about that either anytime. So we'll follow up on that.
If some people dig down the all discussions we had topics like very mobile end devices. You don't want to have state in the intermediate layers. You just want to push the state to the super spine and turn off from the super spine to the leaf rather than very mobile carriers. So we have things like that to optimize very special cases. We don't know if it's useful. So yes, the ideas are floating in the air, and if we are ready to relive them like zombies, if ever needed, right? So it's just unclear that we have a need for highly mobile or highly scalable networks where maintaining state in the intermediate level would be inefficient. We discussed it, we know how to do it, we just did not see a need for it.
Tony again, yeah, so all these things are kind of on back burner because from my side, I see people being entertained by it when I ask them whether they would deploy that or are willing to talk deployment scenarios. I just don't see use cases. I mean, in my case, like SR, right? So there's loopbacks, we talk extensively loopbacks, and I put in deployment considerations, one or two things there, like watch for this in very anomalous scenarios. But for example, SR, it was leaf to leaf, and at the end, you basically tunnel anyway, so why would you even need that in the underlay? But it's simply, that's why these things need standard loving care, because there's simply not enough people pushing for having the deployment need for this stuff. Whereas, for example, the multi-homing of servers has a lot of interest, driven by the hardware coming and the people like realizing that if you can multi-home the servers, lots of problems you're solving today in weird ways just simply disappear, right?
Yeah, I understand. There are things that we talked about before and started to work some work before. We have not really focused on them, and we may decide then they're not worth working on. So just some things that on the list, we can decide what to do with them later. And
So ideally, we should keep these documents alive if later on the need arises. There's some fundamental work how to make segment routing work and use some other things. So yeah.
so blue sheets, has everyone signed them yet? Where are they?
Yep.
Thank you, everyone, and we'll see you in Singapore.
Thanks.
Thank you. Unacceptable.
Young lady.
It's just that, yeah, maybe.
You even exist in life.
Maybe,
It's color everywhere. You grew up already.
Yes, so that.
I was thinking, looking away.
And then I just
Yeah.
saw that.
I have a good friend, he's 70-year-old, and he's old, he's an editor of many years. The guy who
Very beginning, the science books.
very famous guy, just died this week.
So that.
On Friday, I saw him on Sunday.
Yeah, I trust you guys, but.
Peter Wexler or something.
And this is, last week.
6 years ago, but he's very famous.
Yes,
guy.
I was
always,
It's like day one,
Yes.
the way I have.
Yeah.
And he had companies, they have.
Yes, next time you do the review.